should be doing what I'm doing in my pre-calculus classes, and I make them turn in the notes because that forces them to do stuff. But if you don't take notes, then fine. It's right here. All right, I'm gonna get these guys in here and then we'll start taking some notes.
Hi, Mr. Alquist.
What's up, Johnny?
Not much. What's up with you?
Johnny there.
Hello.
You can't hear him because he's in my ear. So
I heard it. Don't worry.
okay, Louise, I won't make you turn in notes. To be fair. But I do want you to do the work. Hey, do you know what's coming up next week? Well, that's it. Next week, is conferences. So if you, and this goes for anybody online or anybody in here, if you are not doing well and your parents don't check Power School, you should probably talk to them tonight and prompt the conversation, because if you are not doing well in this class, your parents just got an email about 30 minutes ago, and not doing well, I mean getting a D or an F. Your parents got an email about 30 minutes ago saying that you weren't doing well and inviting them to conferences by me. So, yeah, if I were your parent and I didn't know about your grade and then it was bad, I would want to know, or I would get angry. But I would, if I were your parent, I would know, because I was that parent that checked Power School all the time, or in that case was Infinite Campus. Okay, so that's that. We are going to take some notes today. And so I'm gonna share my screen. And I think, so to be honest with you, my internet connection was really terrible last week and this week, but I made a fix. And if you were in my room, if those of you that are online, if you were in my room, you could see that there's a cord running along the ceiling, and that's an Ethernet connection. So my computer is hardwired to the network now, and so I'm not using the Wi-Fi, and it seems to be going much better today. But I admittedly am trying to overload it to see if I can get it to crash this way. I haven't been as successful, which I guess is good, right? Okay, so I'm gonna slide away from the picture. For those of you that are online, I'm gonna do my best to monitor the chat and the screen that I have in front of me and the people that I have in front of me. And I'm getting the participant list in here. And so I will do my best to monitor the chat, but admittedly, I don't know that I can monitor everything. I mean, it may seem kind of strange that I can't monitor everything, but I can't monitor everything, you know? This is terrible. So, can you guys see my screen online?
Yes.
Perfect. Thank you, Sadie. We miss you here, but then you're on quarantine. So what are you gonna do? All right. So how many times have you written down the tangent line if you were in my class? If you say none, that's not fair. You should have at least written it down once. So here it is again. We're going to talk about the tangent line again. At one point in time, I told you if you were in my class to write it down 10 times, you'd know it. This is now maybe the 11th time or more that you've written it down. So to find the equation of a tangent line, you got f prime of a, and that's generically f prime of a. So that's just a derivative. Okay, I gotta keep on letting people in as they go. This is really hard. This is why I'm bald. I think I went bald this year. That may not be true. Orton's back there laughing, like, nope, you were bald last year. And then you got a point. You got a comma b or a comma f of a. So to write the equation of a tangent line, you need a derivative and you need the value of a function. Those are the two things you need. Now, we're going to talk about the chart. Now, you've written the chart down how many times? Don't say, you may, okay, once. So even Ryan's written it down once. So that's pretty big, right? So the chart, you should know this probably by heart as well. The one thing I'm going to do is I'm going to unpack it a little bit differently, and I'm going to put some other functions in the columns, because now we have integrals that our function might be defined using an integral instead. Okay, Maddie. Oh, nice. Okay, so you could have g of x be defined as the integral of h. What that means is to get to that middle column, you would have differentiated g, but if you differentiate an integral, you just get the function that's inside of it. And that's a big piece. And then if you differentiate g again, you would just get h prime because of the way that one was defined. So that's an important piece to note, because AP will do that to us oftentimes on free response questions, where they'll start out and define a function to be an integral. That way we can move all over with it. We can test you about integration, and then we can just differentiate it, and now we're testing about differentiation. So they'll do that frequently. And so initially I unpacked it as f prime, f double prime, but now we can kind of think about it in another way. Any questions on that? Can I move on? Okay. Now, I'm going to scroll this out, and I know it gets a little small, but I want you to see this whole thing. So I generically drew a graph on there. I generically drew a graph on there, and I made it, and know that like this t and the x, and you can see that I changed, the bounds are in x, but the function is in terms of t, and that's because in calculus or in math, generally speaking, those are kind of the same variable, but kind of not. I mean, one represents the values on a graph, and the other represents the x values of the function g. And so we kind of have to distinguish them. If we've just made them all x's, we wouldn't know what we're talking about. We wouldn't know, are we talking about the x value that's a bound, or are we talking about the x value that was on the graph? And so we have to kind of, so that's why you'll see this. It's not a huge thing for you to be too worried about. It doesn't really change anything other than the way we write it out. But know that, like, if we have this function g, and it's defined as the integral from a to x, that's just the area underneath the curve. That's how we define it. But then if we differentiate g, that would just be f, and that's just the value of f from the graph. And then if we differentiate g again, so we get g double prime, that's f prime, and that turns into the slope, right? I mean, so all of this is not new. It's just how do we think about it if it's defined as an integral to start out with. Can I scroll up? Are you guys good online? You guys got that copied down? I don't want to move too fast.
Wait, what is that T minus A something B up there?
T minus A something B.
To the right of the graph.
Oh, T, it's the T axis. This is axis. Oh, fine. I'll write it again.
It was
Mr. Ott-
messy. It was messy.
Sadie says it's messy. How's that? Is that better?
Yes.
Okay, thank you. I am sorry. I just started writing like Austin. If you've never had him, his handwriting is terrible. And it slopes down. Any questions on this? Okay, the last general piece of notes, and then we'll do some examples. The last general piece of notes, you've written this down. Well, in theory, you've written this down. It's finding the absolute minimum or maximum. There is 4 steps to finding the absolute minimum or maximum. You know how do you know whether it's asking you to find an absolute or a relative minimum or maximum? It'll say, but what will it say? Which one is specifically described, absolute or relative? Absolute is described because they'll give you a set interval. When you're asked to find a relative minimum or maximum, the actual word relative or local will be in the problem. So if you don't see the word relative or local, then you know it's absolute when they're asking for it. And so some of this, I was talking about 6 hour, I was like, some of it is just understanding, what are they asking you? What did they give you? And then what are they asking you? Because if you know those things and you can extract that information, you're well on your way to solving questions. So in this case, the first thing you do is you find the critical numbers. That's where the derivative is equal to 0 or undefined. The second thing you do is you make a table, and the table should have the 2 endpoints that you're given and any critical numbers in between those 2 endpoints. The third thing you should do is calculate what I call the Y value. And I put it in quotes because it could be an F value, it could be a G value, could be an H value, whatever that other value, that value in the right column is, the right table. And then the fourth thing is really important. You actually have to go back and answer the question, right? I mean, you got this table and you've done all this great work. Oftentimes we'll see kids students that responses that don't answer the question, but it's sitting right out there in front and they think we're supposed to sort of interpret what this is, but we don't want to do that, okay? So I'm going to do some examples and I need to, don't write this down. Yeah, so the question is that you guys didn't hear online, but is AP looking for those 4 things? And the answer is yes. Usually it comes in 3 points on a, it comes in 3 points on an AP exam question. And the 3 points are finding the critical points, making a table and calculating the Y value. So the second and third step is a point. And then the fourth step is answering, or the fourth one is a point that kind of also goes along with the table. So usually that's worth 2 or 3 points. If it's worth 2 points, there's a point for number 1 and a point for parts 2, 3, and 4. If it's worth 3 points, it's a point for number 1, a point for 2 and 3, and a point for 4. That's generally how the FRQ is. And that's why I say make a table, because it's also your justification for an absolute minimum or maximum. The table actually justifies it because you're looking in the right places. And often, and sometimes that table will actually get that first point as well, depending on the question. So let me, I'm doing my best to see if I can organize this, but I gotta shrink this down and get delta math. But I gotta grab a hold of it right here. Hold on. I'm not doing this question. And those of you that are in the back in the room, I know it's really hard to see. And I'm not sure the best way for you to, there. Okay. So can you guys see that in the back? Because I can't see it very well. But I'm going to do my best. Okay. So this question, so this example says, we got this integral, we got this function g of x, and you don't have to redraw the graph, okay? So don't bother. In fact, maybe what you want to do is just write some of the things that I write down here, because redrawing it, you're going to get plenty of time to do the problem. But it then asks you to find g of 5, g prime of 5, and g double prime of 5. And it actually doesn't ask you to find them. It just asks you to identify, are they 0, negative, or positive? That's what it's asking you for. So so just extract them in each individual part. So g of 5, that would be the integral from 5 to 5 of f of t dt. So I want you to think about that, okay? Knowing that the integral gives that area under the curve. So don't answer it out loud, but I want you to think about it without texting and using your opposable thumb if you're in class. If you're online, somebody unmute themselves and tell me what the value of that is and why. And if you're in here, somebody tell me what the value of that is and why. Why is it 0? Because you didn't go anywhere. Nobody online unmuted themselves, but that's kind of sad. But the answer is the value of this is 0. You didn't go anywhere. You started at 5 and ended at 5. You literally went nowhere. Okay. So g of 5 down here. Oh, where's my mouse? Uh-oh. Now I've done it. I've overloaded the screen. Shoot. You guys can't online. Can you guys see it anymore? Can you even hear me anymore?
Yes.
Can you see the screen anymore?
Yeah.
They can see it on there. Okay, hold on, because we can't see it here. Hold on. Uh-oh. My Apple TV is bad. Okay, those of you who are in class, you now have to go to your computer. Sorry, and log on to the Zoom. People in class we lost Apple TV. So hold on. Okay. So I'm going to do my best to rearrange this. Hold on. And I need. Okay, sorry about this, you guys. I tried to overload my computer and it worked. Okay. Now everybody should see that. Can you guys see that screen now? Okay. So this will be easier for me. I just won't have to be as close to Ava. Sorry. Oh, I didn't mean that. I didn't mean that. I'm sorry. I was thinking I know, forever. I was looking at Ava and messing it up. So I got a lot of things. I got a lot of problems. Okay. Okay, so you can see this now, and now I'm just gonna organize this. So now, if you're looking at, so we could say G of 5 is 0, because we didn't go anywhere, okay? But now, if we're asked to find G prime of 5, what's that the same as in this problem? That's the same as F of 5. So since that's the same as F of 5, since that's the same as F of 5, that's just the value on this graph. Well, what's that equal to on this graph? 0. And then the last thing we're supposed to figure out is G double prime of 5, which is the slope, which is F prime of 5. And notice that on this graph at 5, this graph is decreasing. So this is going to be negative. Does anybody have any questions on that? I don't even know if anybody is online is even listening to me anymore.
Wait,
We're listening, Mr. Alquist.
Thank you, Johnny.
You're welcome.
wait, so you wouldn't try and like find the slope, you would just say that it's negative?
Well, on this particular one, your choices over here are this. Less
Oh,
than
okay.
0, 0, or greater than 0. So we would say less than 0. And this we would say equal to 0. Okay? For this problem. Because we couldn't actually calculate that. We need an equation or something else. Okay, so then we're going to talk about tangent functions, tangent lines. So this is a question that, and again, I mean, I don't know how much you want to copy because if I have you copy the whole thing, you'd have to copy this graph, and you're gonna, and I wouldn't bother necessarily copying that graph, but you maybe can say from the graph. But this is a second type of problem that you'd have to do. So again, you got g of x, and that's the integral from -9 to x of f of t dt. And it says write the equation of the tangent line when x is equal to 5. So again, we're starting at -9. That's way back over here. And we're going to go to 5. So we need two things to write the equation of the tangent line. We need g of 5 to get our point. And we need g prime of 5 to get our slope. Those are the two things we need so we can write the equation. So the first thing we need to do is kind of go, okay, well, I'm going to do the easiest one. And I think the easiest one is g prime of 5. So g prime of 5 is also f of 5. Does that make sense? And f of 5 is right there at 0 in this problem. So we know our slope is 0. So actually, at this point, we have almost all of our tangent line. Like our line is y equals 0, x minus 5 plus, and now we just got to figure out what that other value is. So now what we're going to do is we're going to take and we're going to go from -9 to 5 of f of t dt. Well, if you did all the work last week, you know that all that is calculating the area, right? So that's calculating the area. So if you think about like this first one, going from 9 to 7 is a span of 2. And the height of this triangle is 5. So this value is 5 because it's that triangle. I'd probably split this next big piece into a triangle, a rectangle, and another triangle. So this first triangle right here is the same size actually, but it's -5 because it's below the x-axis. this rectangle from -5 over to 1, and if I were to kind of symbolize it, I guess I can do this. So this part is 5. This part right here is -5. This part right here is a span of 1, 2, 3, 4 down 5. So that's -20. Everybody with me there? So we got -20. And then this triangle right here is a span of 6 by -5. So but 1/2, 6 times -5. So that's -15. Is that right? So -15. And then that value, so that's -35, goes right there. And that's the equation of that tangent line. I know that equation of that tangent line is just y equals -35. The horizontal line. Don't simplify it if it's a free response question. Just leave it like that. Because if you simplify it, only bad things can happen. You're not going to get it more correct than that. You could just make a mistake, right? You can't make it better. I mean, y equals -35 is the same equation. Those are equivalent equations. So don't simplify it if you don't have to. That's the name of the game. And you've never heard a math teacher say that before until now. But now you have. Okay. So then we have other questions like something like this. Now this is that max min thing. You got 2 more examples and then I'll let you go. So on this one, we have this graph, and again, if you notice, every problem that we've had today has been this function g of x that's defined as an integral of f. It's a pretty common practice that AP will do this as well, because again, we can kind of go a lot of different directions in this. We got -7 and 8 in here, okay, and that would be another way. So there's 2 ways to know that they're asking for an absolute maximum. One is when they say the word maximum, they don't use the word relative or local. And the second way is what Fiona said, is that we have a set interval, -7 to 8. It tells us where we're supposed to start looking and where we're supposed to finish looking. So the first thing we're going to do is find the critical numbers. And that's when g prime of x, which in this case is equal to what? What's g prime of x the same as? F of x, when that equals 0. So when this graph equals 0, this graph equals 0 when x equals -7, when x equals -4, when x equals 0, when x equals 4, and when x equals 8. Those are all the critical numbers, 2 of which also happen to be the endpoints. So now what I'm going to do is make a table. So that's the third step in this thing, right? I'm making a table. And my table is going to have x over here, -7, -4, 0, 4, and 8. And over here, I'm going to have g of x. And g of x is the integral from 0 to x of f of t dt. So when I have to calculate each of these, the first one, I'm going to calculate the integral from 0 to -7 of f of t dt. Well, so I'm starting here, and I'm going to calculate the integral, which would be this space below the x-axis, that's 13, and this space above the x-axis, which is 9. But remember, I'm going from 0 back to 7. So it's 13 minus 9. Does everybody understand why it's that way? If you don't, you might not have done the work from last week. But in this case, that means that value is 4. Now, you could keep on writing this. I'll write the next one, but I probably won't write the one after that. But if we go from 0 to -4 of f of t dt, that's just going to be 13. Does that make sense? And what's the value of 0? 0. Now, what's the value of 4? -14, hopefully you said. And the last one would be -14 plus 10, which is -4. Now, we're almost done. We just have to answer the question. So what is the maximum value of G? Yes. This is the maximum value. That is the answer. For AP, if it was a free response question, here's what I would write. I would write the maximum value is 13 and occurs when x equals -4. That's what I would write. If I were writing a free response question, that's what I would write. And boy, that writing, I'm surprised you didn't complain about that, Sadie. She's on here. And she complained already about my writing. So it is 13 and occurs at -4, and that's the value that you put in there. Okay? So one more example, and then we're going to be done. And the last example deals with this diagram. And you've seen this diagram. The position down here, the velocity is here, and the acceleration is here. We differentiate to go up the steps, and we integrate to go down the steps. Okay? So here's what the question looks like. The questions that you're going to have is something like this. So this idea, does anybody need more time to copy that if you're copying it? Okay, so I need you to maybe write this down. A particle moves along the x-axis. What that means is that's like moving on a road. So just think of that as some particle is moving on a road or a track or something. And that's an important piece because I think people get kind of confused about X's and T's and what's happening. And so when they describe that, they're just saying that it's moving left and right. And that's important because if you take physics, you know you can move in a slant way, but we're not doing that in this case. We're moving left and right, and that's the only way a calculus question for AP is going to be asked. So now what this is saying is the velocity is given by this graph. So here's the velocity. So we're given this. And it says, find the total distance of the particle traveled, which means we're asked this. And that's an important piece, right? So if you know what you're given and what you're asked about, you know what you have to do. You should know, oh, we're going to have to integrate this to figure out our answer. Now, we're asked to figure out the total distance traveled from 0 all the way up to 18. So here's what's happening in this case. We got this road, and the particle is starting somewhere like this at t equals 0.
Didn't they say 10 to 18, not 0 to 18?
Oh, 10 to 18. Thank you. 10 to 18. So we're starting right here, and we're going to here. Now, if you think about this space right here, this space right here is a right movement because it's above the x-axis, which means if it's moving left and right, this is going to, because this is positive, it's a right movement. And it's a right movement by going over 6 and up 4. And so 1/2 base times height would be 12. So it's going right 12. Does anybody have any questions about that?
Yeah. Why are you finding the area when it's just moving?
Because this is the velocity. So remember, if we're given this velocity right here, and we're asked about the position, we have to integrate velocity to get position.
Oh yeah, I forgot that. Okay.
Good question though. So what's happening is we're going to the right 12 units. And at that place, that's t equals 16. And then what's happening is right here at 16, the particle turns around. The velocity is 0, so the particle turns around. And we go left this many units, this area right here. So that's 2 by -4, so -4. So then at 16, we go back this way 4 units. So on this problem, the total distance traveled is how much?
8.
It is not 8. I will say the displacement is equal to 8. The total distance traveled is 16. The reason the total distance traveled is 16 is distance doesn't care which direction you're going. So like if you leave your house and you drive to school and then you drive back home, your displacement is 0 because you started and ended at the same place. But your total distance traveled is, like in my case, I live 7 miles from here. So my displacement by the time I get back home is going to be 0, but my total distance traveled is 14 miles. So I drove 7 miles here, turned around, drove 7 miles back. So in this case, the particle moved 12 miles to the right, 12 units to the right, and then you moved 4 units back. So it went a total of 16 units, but it was displaced 8 units.
So then why did
Okay.
we think of it like in terms of like moving left and right if that doesn't really matter?
Because I wanted you to understand the difference between total distance and displacement. Because sometimes you're asked total distance, sometimes you're asked displacement. You can be asked either one, and I want you to know the difference between them. Okay? Does that answer your question?
Oh, yeah.
Perfect. Okay, that's it. If you need more from me, you could stay on here and ask me. If you need, if you're done, you can go. If you're missing a lot of assignments, you should probably get caught up, especially before next week, right? Especially if I emailed your parents, which
Bye,
can't be
Alquist.
undone.
See you
Bye,
later.
Sadie. I am sorry, Ada.
Thank you, Mr. Alquist. You have a good day.
Bye, Johnny.
Bye.
But I'm going to guess. I don't remember a time, but I'm going to guess there has been some time over the past 2 years since we've known each other. We've known each other more like 4 years, that you've called me Austin. No. No? I feel like everybody's called me Austin before, and I just say that's the other bald guy.
I've never had
Oh, then that would do it. But anybody who's had Austin and had me will change things. What do you need, Miss Davis?
I had a question about like U-substitution
Yeah.
in like instance. So like when are you supposed to like know when to do that and when to not to?
So the short answer is if you wrote out if you wrote out all of the rules, like you've written out all the rules maybe, and if you have, the rules are pretty straightforward. Like the integral of u to the n du is equal to u to the n plus 1 over n plus 1 plus c. Now, oftentimes the rules are pretty basic. There's nothing really super fancy about the rules, like the integral of 1 over u du is equal to the natural log of u. And the integral of sine u du is equal to negative cosine u plus the constant. Most of the time,
Wait, why didn't
these
you write
rules,
a constant for the first one?
I did.
Oh, you did. Oh, it's blocked by the Zoom.
Oh, so the short answer to your question is we almost always use, unless it's pretty generic and basic, we use U-substitution. Because the rules, like we wouldn't need U-substitution if it was integrate 3x to the 4th plus 7x squared minus 3. Okay, because that follows the rules pretty easily. But if we have the integral of 3x squared plus 5 to the 5th times x dx, that one, the rules don't follow that very well. So we'd have to use U-substitution on that one. So that's why, if you remember, if you did it, great. If you didn't do it, about week, I'm going to say it was like week 2. I think we're in week 6 now. In week 2, I had you print off a copy of all of the differentiation and integration rules, and you were supposed to fill it in. And if you did that, you'll see most of the rules are really, really super basic.
I did do that.
And so if it doesn't follow one of those really, really basic rules, you're probably going to use U-substitution, honestly. And technically, you could use U-substitution on, x to the 5th. Because I could say, well, u is equal to x, so du is equal to dx. And so this is the integral of u to the 5th du, which is u to the 6th over 6 plus c, which is x to the 6th over 6 plus c. Like, we could have done U-substitution on an integral like that. We wouldn't need to, but we could have. So technically, you could always use U-substitution.
Okay, thank you.
You're welcome.
Okay, bye.
Bye.